Well, thank you for joining, everyone. Hopefully, we get a few more faces. But tonight we're going to be talking about lambdas, caching, some microservices, and everything in between. Derick will be doing the first part. I'll be doing the second part. As usual, we will do the Q&A at the end of the session. So Derick's session is 20 minutes, and then we have the Q&A. And then we have my session, which is also about 20 minutes, and then a Q&A as well. And in that last Q&A round, I will be sharing a link to a short survey that you can fill in. And that's your entry ticket to win one of two $25 AWS credits if you want them. And then I think that's mostly it. You are encouraged to turn on your video. It's always nice to speak to some friendly faces. And
yes, please.
Then Derick, you can take it away.
Awesome. So just to make sure you guys can see my screen, right?
Yes.
Awesome. Okay. So just some background about myself. I'm Derick Schmidt. I'm from the Free State. I'm a farm boy, and started writing code at very young, and milking the cows in between. So that's quite interesting to start from. Then, so because of that, I actually always knew I wanted to do some computer stuff. And then I came to Stellenbosch to actually study computer science. So it was called B Engineering Science, and it was applied maths and electronics, and also some computer science. But the electronics got me. Those Fourier transforms kept me at university way too long. So that wasn't so much fun. But then I really knew I needed to do programming. So I worked for a few companies in Stellenbosch, and in 2014, I actually found my way to the cloud. And those days it was still just a virtual machine in someone else's data center. So 2014 was fun, and starting to play with it and figuring out there's a load balancer that won't cost you millions of rands actually to just try and load balance things. So it really made some things for us easier. And then 4 years ago, I joined Capitec, and when I joined, I helped the guys from Prolexis, that's a machine learning company, to actually build the first cognitive platform for Capitec, and that was done in Azure. So we used batch data with streaming jobs and Spark and Databricks, and we started playing with Kubernetes then, and we have machine learning models and built all of that in Azure. And then the last 2 years, we've been playing with AWS, and now we're doing some more awesome stuff like streaming data, not just batch stuff, and still Spark and Kubernetes, and just building out the nice stuff to play with, not just VMs. And now lately, I've been busy with looking at the client data platform, and now we're going to try and get a single view of a client in the bank. And what that means is just connecting all the clients we have across all the business units together. And we are trying to do that with graph databases and still machine learning and all cloud stuff. So from streaming to serverless, anything that makes our lives easier we can use. So it's really nice to actually play with stuff and be able to use the newest and greatest things. One of my hobbies is FPV drone racing. That's really great. I always wanted to be a pilot, but I know I will never have the money. So I do FPV drone racing. That's the same thing as flying for me. And then mountain biking, just to make sure that I still keep fit, and then running after my 16-month-old boy. And Paul already met him. He's quite a handful in a meeting. So it's fun times. So I actually just want to talk today about a Lambda caching rabbit hole. So why I came up with this name is actually because firstly, we thought, yes, it would be so awesome to just do this one very simple task in AWS. And our requirements were quite easy. It's like receive events from AWS EventBridge. And then when we receive it in the Lambda, we need to invoke a RESTful API for each event. And the API is hosted in AWS, that is in an Elastic Kubernetes service in EKS. And then this API is actually secured by OAuth 2, and the identity provider is not in AWS. So all of this is quite standard, and then your IDP is not in AWS. So that makes stuff a bit interesting. So attempt number 1. So it's quite easy. Solution EventBridge, insert the Lambda in the middle, and the Lambda fetches the token. And if it has the token, it calls the API. And that's quite easy. So the challenge is on this approach, right? So you guys can see, I'm just going to use the pointer. So firstly, when you start to use Lambdas, you do things like, if the function is called like this and you call the token in here, it's actually called every time. So that meant that we actually fetched the token from the IDP all the time, and we get millions of events. So the IDP wasn't happy. So the challenges were no caching, too many calls to the IDP. We have millions of events, and events are unpredictable. So then what we did is, okay, what are we going to do to make it better? So attempt number 2. So the easy way is actually just execute the token fetching once. So basically the easy type of caching in Lambda. So you just, this is the Python one, but it works the same in other places. So you store sort of a global variable, and then you fetch it once, and then you can use it. So now we have less calls to the IDP, but because we still have unpredictable events, the Lambda starts and then stops. And then if it starts again, it just fetches it again. So still the same. So still too many calls to the IDP. We still have millions of events. We still have unpredictable events. And then we thought, okay, let's make it even better. So attempt number 3. Okay, first go to the IDP, fetch the token, store it in parameter store, and then we follow the same. So this is already a bit better. We saw we had to enable the enhanced throughput on SSM because it also got stuck that it wasn't fast enough. So less calls to the IDP, but we still had millions of events, still unpredictable events. And now we had the dreaded 429 error that says you should actually back off a bit. And the reason for that is because of the unpredictable events. If the Lambda start up and, for example, we get 1 million events now, there's like 900 starting up at the same time, and all of them try to fetch the token and then try and place it in the parameter store at once. And if 900 does that at the same time, parameter store just says no. Then what we did is attempt number 4. We just swapped out to secrets manager, since secrets manager has a higher throughput. However, we still had the same issue. Now we started to think of, why is this so difficult? What can we do? Spend some time with the AWS guys, and they pointed us to a blog post that is very dangerous. And this dangerous blog post is that you can actually, to your Lambda, add an extension that is written in Golang or Node, and that will give you an API, and the API will call wherever you want to fetch or store your tokens or config. And then after that, it will just call to the internal API, and then the rest will be better. So the good there, the response times now is better. I also learned Golang, so this is awesome, but it's way too complex. I mean, if this falls over, it's really not good, because there will be 1 or 2 guys that know how to fix it. And we still got 49 errors because we still had the problem that the Lambda scaled too fast, and then too many spin up at the same time, and then we still had the same issue. So there was no basic locking mechanism or a mutex or something to show the Lambda that one should get it and the other should just wait. So then I went a bit further and thought, attempt number 6, okay, let's step back a bit. So first we removed the Golang API extension. That was just a crazy thought, and it was cool and so on. And I tried to talk to the guy that wrote the blog post, but he didn't answer. So I think he actually knew it wasn't so great after all. But the thing that we came up with then is actually have a Lambda that just fetches a token every X minutes. It actually gets triggered here at the top. CloudWatch event every X minutes, it's triggered. fetches the token, stores it in a parameter store, and then all the other Lambdas that receive events just goes there and fetches it, and then it goes on with its life. So it's really cool. Now we actually have a way better solution, and we basically have no more issues, but not really, because we still have millions of events, and the events are still actually unpredictable, and our APIs and EKS scale way too slowly. So Lambda can go to 900 concurrent instances quickly, but our Docker containers running in EKS did not. So that was another thing that we had to solve. So why are these events challenging? It's actually just because of events. Mostly most event systems out there don't give you one every second or one every 100 milliseconds. It's reactive, and it happens on when someone logs in or when a user does something or so on. So it's not predictable. So you always have spikes. Like here you guys can see, here's a spike almost to 4 million events, and down here it's almost zero again. There it is totally zero. So it makes stuff difficult. So your arrival rate is not predictable. And then the complexity, like I said, that it brings is Lambda scales too quickly. Multiple Lambdas try to cache the token, and still the same issue with the error 429s. But it's way better now, and fetching it with the Lambda with the token really actually solved our problem. And then so in the end, I'm just going to go back. We actually solved the problem with this. So from a simple requirements, this is actually more components that we bargained on, but this solves the problem. Security is not always so happy to cache a token, but you can come around it if you can explain why you're doing it, and if you build in all the relevant IAM roles and permissions so that just these two Lambdas can access it, then it's fine. But it's still a conversation to have. But now in the end, that was all great and so on, but there's some stuff still to learn. So now the caching problem is gone, but our next problem was don't DDoS yourself. So what happened is, like I said, just the Lambda scaled too fast, and then we actually just killed our own API, and we couldn't scale fast enough, and we didn't want to actually just keep them scaled up, right? Because then we're wasting money on the other side. So what we did is we introduced the SQ, and then we had our Lambda, and we set the Lambda's concurrency to X amount, and then as the unpredictable events come in and they go up and down, it actually smooths it out, basically. So it's almost like a filter, for example. So now we can control how fast we process it, and if we really get a lot of events, we have a trigger that sends an alarm, and then we can set the concurrency on this Lambda to be more, so it can handle more. But now we have this awesome new thing, but we still have a problem, right? So if Lambda fails to process an event, what happens then? So now is our last wonderful solution is how to make that better, is how to handle the failures. So we use the SQS here that can then actually, it triggers the Lambdas, and whenever a Lambda tried to process the event and it failed a preset amount of time, then it will add it to a dead letter queue. For us currently, we don't see a lot of failures, so we have a manual reprocessing that happens. You can make it automatic, but then you might build in a nice, good old circle here. So that's not going to be fun either. So you might pay for events that will never get anywhere. So for now, we decided to just leave it a manual process. So we have an alarm that triggers, we can log in and then fire the reprocess Lambda if we see the state of the event and why it failed. So in the end, actually, these simple requirements led to all of this. And that's part of the difficult thing and awesome thing of serverless. It sounds so simple, but it's actually very complex. And Rehan actually wrote quite a few blog posts. So I met him through reading his blog posts to read up on serverless and Lambda and so on. So you guys can spend some time and read his stuff. It's really great. And yeah, that's why I thought we should just share this. So if you ever have these simple requirements, this is what we came up with in the end. And yeah, it would be way easier if our IDP wasn't in the outside world, but in AWS it would be nice. But yeah, most bigger companies I think have that challenge that your IDP is not inside AWS. And then I have questions. I think that went quite fast. So if we missed something, I can go to the slide. Anyone, any questions?
Derick, can I ask you
Quick
something?
one. Sorry, go, Paul.
Yeah.
No, go. I'll wait.
Your choice of identity provider, has that been determined beforehand, or do you have a choice to change it? And if you looked at Cognito or any other identity provider, where would you look?
Yeah, so the thing is, yes, unfortunately, we couldn't choose it because on premise, we already have an identity provider in Azure, so we needed to choose one of them. We couldn't federate all the users to a new one again. And then what I would choose is, I'm actually busy trying to choose, and it's very difficult because Cognito is great for simple solutions, but if you do more complex stuff, it's not that easy. And you guys won't believe me how insanely pricey it is. If you want to use Cognito for 8 million sign-ins or active users a month, you will pay, what was it? I think it's more than $1 million a month, R1 million a month to do that. We can actually check it out, but yeah, Cognito is too much. So if I have the choice and I can buy something with my money, I will buy Auth0. They're really nice and they support a lot of things, but it also comes down to requirements. So Okta is great, but they're also very expensive. But yeah, I would actually have loved to secure these APIs that we have running here with just IAMAuth, add some stuff on there. So it's all basically calling STS, the simple token service, and then securing our APIs here. But these APIs are consumed by channels, and channels are things like the mobile app and other things that come from outside of AWS, and we're already have them supported in a similar environment. So we didn't want to go to auth mechanisms. Did that help, Basil?
Yes, it did. We're busy building something, and although it won't scale to 8 million, we certainly just want to be aware of what the best options are there, and potential problems. So yes, this is valuable to us.
Yeah, we can talk offline as well. I have some more info to share, and then maybe we can help each other out, because I also feel all of us don't have to hit our heads against the same wall, right?
Thanks for the offer, Derick. I'll back you up on that.
Anytime. Paul?
Did you guys play around? Like, I know it's a security token, so you couldn't just store it in the Lambda's environment variables. But did you ever play with that, like pushing, like updating the Lambda that's actually running, like updating its environment?
No, we did not try that actually. I didn't actually think of that, so I should have actually talked to you before, and then we might have tried it. But I missed that one.
I've never done that, like a running one. If you've got an active instance of a Lambda and you update the environment of that Lambda, if it will reflect in those active ones.
I think it'll take a bit of time, right? If I just think about maybe what's in the back end of Lambdas, it must be something like a Kubernetes type of thing with mounted secrets or something, and that's a drive that needs updating those things. Well, if I just imagine, I have no idea what's behind it, but Rehan, maybe you saw something.
Yes. So what actually happens, like when you update a Lambda function, there's actually two update calls. One is for your configuration and like your VPC and anti-security attached to it, and then the other one is for your environment variables. So there's two different endpoints that need to be called, and that's why it's dangerous to just update a Lambda function that has a lot of traffic, because if you do that, then some of your Lambda functions will have the old variables and some of them will have the new variables, but that's for a very short split second or two until they all have that new variable. So that's why people use versions, it solves that problem where the version will first do both updates and then the traffic will switch over to that Lambda function. But Derick, are you still there? Well,
Yes, sorry, I just
happy.
need to go. Our little baby isn't happy, so I need to help. So
No, that's fine.
I'll be back soon.
Okay, because I have a question for you, but I'll.
Yeah, you can. I can quickly. I think it sounds quiet again.
Yeah, I also have one when you get back. I also do have a question.
Okay, 2 minutes. Sorry, guys.
No problem. Let me then start sharing. There. Okay. Okay. Can somebody see my screen? Just give me a yes, no. Yep. Okay. Cool. So I'm going to be talking about refactoring a distributed monolith to microservices. Except that I'm not going to be talking about that. So sorry for the misleading title. What I'm actually going to be talking about is like moving from a monolith to a resilient microservice. And the reason for the title change is that like a few weeks ago, I put out a picture on Twitter, and that changed my definition of a distributed monolith. And that's why we're also going to look at all of the categories in between a monolith and a microservice. So who am I? I'm Rehan from Merwe. I'm a developer, architect, and AWS junkie. I blog, I speak, and I am in like basically every AWS Slack channel that you probably know of, and I have a blog. And yeah, well, I'm just focusing on serverless and everything that AWS has to offer. So everything fails all the time. This is a very famous quote from Werner Vogels, and I like to remind myself every now and then to actually just think about this when building systems. So for my example and my presentation, I want to model all of my architectures around this business logic or this pseudocode of where we create a client and then we create a person against that client, and then we increment the person counter for the client. So we are basically just keeping track of how many users or persons are on that client, and then we will notify the client by email when they get a new user. So for a monolith architecture, we'll see that a monolith shares business logic. All of the code and everything is in one application, and that it is deployed as one application, and that there's no physical boundaries between our code, so between our resources like a database and things like that. And I'm a picture person, so that's why we have this. Our black box is our repo or our pipeline, just to indicate that we deploy this as one. And the blue box is the indication that we are sharing code within this service. And then the green one is just there to indicate that this is the stack within AWS, meaning it's like one unit. And on the left, we can see the person doing the API calls against API gateway. And then all of that logic that I just went through is being done on that single Lambda function. And this, it's a Lambda-lith, and yeah, I'm a big fan of that, but I'm not going to go into that in this talk, because even if you do this, even if you create multiple Lambda functions for your service, it's still a monolith, because you're still sharing code, it's still being deployed together, everything is shared, like in essence. And even if you create like different entry points and different other services within your monolith, it will still be a monolith. Just checking out the chat. Do something urgent. And even this is a monolith. Even if you create different stacks within your application and deploy them as one, you're still sharing code like within that monolith or like within those services, and it's still deployed as one. So it's still actually a monolith, even though your infrastructure stack and like those compute stacks which don't carry state are separated from those stacks that do carry state. And this is much better organized, and you have better control and security over it like this, but it is still a monolith. Next, we can break down our monolith into two smaller subcategories. And this is where the word modular monolith comes in, and distributed monolith. So if we look at a modular monolith first, next, then we'll see a modular monolith. They have strict boundaries between code or services, meaning that these services don't share any code, which is very good. That's what we want, but they're still deployed as one unit, and they might or might not have physical boundaries, and that seems confusing. But if we look at our picture, we'll see that the person service there at the top is now containing all of its business logic within it. Only it can store the person objects or do whatever it needs to within the database. And the similar with our client service. It's like it is only one that contains the client logic and uses the database for that. The purple arrow is an indication that now, like with our pseudocode, we said that whenever you create a person, you also need to increment that counter on the client object to say, or like to keep track of how many users are on that object or on that line. And that's what that purple is there for. It's an indication that we have to go through the API gateway of the client, then to the Lambda, and then it gets stored on the database. And this is this introduces latency, and a lot of times people like realize this and then they take shortcuts. And this is where the distributed monolith comes in. This is the worst of the two monoliths that we have here. And we'll see that there is loose boundaries, that they are sharing business logic and they are deployed independently. So that's actually good, but they can still access each other's resources, even though they have physical boundaries between each other. And that's because of that sharing of business logic. It just makes it easy to do that unconsciously, actually. And it translates to this, where each service now has their own black box. But if you look, the blue box is now spanning both services, meaning they both can access each other's databases unknowingly, maybe. So it's now much easier for the person Lambda function to just speak directly with, say, the client add function, and then it inserts data into the client database without going all the way through the API gateway, like to the Lambda function, and then storing that data. So this is a very tightly coupled service, or like microservice or monolith, which is actually bad. You could actually like rather do a normal monolith, or a modular monolith would be better. For the microservice, finally, the big one, and here we have strict boundaries between our code and between our business logic. We deploy them independently, and we always have physical boundaries between our services. This translates to all of the boxes being around one service. And again, the purple arrow is there to show that now our person service still has to go through the API gateway Lambda function to store the data, or like to access that client data. So I'm going to go a little bit further, and I'm going to make it a bit more complex by now splitting out the communication part of our person service, the one at the top that sends the email or the notification to that client, notifying when the person is added. It just translates to this, just 3 services, being very simple. And on this piece of paper, this looks like a good idea. It doesn't look too bad, but as soon as we bring it back to our pseudo logic, we see that we have created very tight coupling between our services. And we'll see that at number 1, so when we create a person, we store the person in the database, and then we send off an event, or like we do a synchronous HTTP call to our common service, or that service that's like responsible for the communication. It then needs to go and increment the client person, or like person count field on the client, comes back. It then needs to get the client name, comes back, and then it sends, or then it can send that email to the client saying how many persons are now on the client object. Only then do we return the response to the client making the request. So this is very tight coupling between these services. If the common service goes down, or if the client service goes down, then we can't create a person. And that's not really what we want. We want the person service to still be up and running, even if one of the other two services go down. And we can achieve this by different means, but I'm going to look at EventBridge. And EventBridge is just a kind of service bridge or broker that just takes in events and then forwards them on, and then other AWS services can listen to these events and then process them. And this allows us to decouple some of our logic. And if we look at that in our example, we'll start with the create person. So when we create a person, we are now just storing it in our database, and then we are emitting that we have created this person onto the event bus, this event bridge. And the event that we're putting on that bus looks like this. The detail type says person created, and then we have the detail over there saying what this person's name is and what client we're adding them to. And like the rest is just some metadata around this event. Like similarly for our client, we just come in the API gateway, Lambda, we store our client, and then we emit an event onto the bus. But this time the detail type is client created, and now our detail is different. So from an XML perspective, everything still stayed the same. And all of the API endpoints and contracts are the same. But now each one of those services is only concerned about storing its own data and managing its own data. And the person create call is much faster. It's much more consistent and reliable because it isn't depending on our other service. But from an internal perspective, there's some other things happening. And if we have a look at that, we'll start with our create client. So we looked at number 1 and 2 when we create the client, we emit that event. But now our common service, we don't have an API gateway here anymore. We like threw that away. We just have our Lambda function, and then there's EventBridge rule that says if I get an event which has a name client created, then it invokes this Lambda function. It then gets that event that we saw, and it then stores only the data that it needs. So it will store the client ID and client name and client email address, because that's the only data that our communication service really needs to operate. And this then breaks our dependency that the common service needs to do a direct request to our client service to go look that up in like near real time. That isn't needed anymore, because now our common service is storing a copy of that client data. And they call this pattern the client state transfer. Yeah, something like that. It's like further down the slide. I'll just double check that word, but that's what this pattern is called, where you basically store some pieces of other service data internally for your own usage. You'll be less dependent on them. Because now with our person create flow, we looked at number 1 and 2 where we store the data. And now I first want to give attention here, because that event is now on the bus, and now our client service is also listening to person created. And when a person is created, it's just going to increment that counter on the client, and that's how we're going to increment, or like keep track of how many users are against our client. Like that responsibility shifted from our common service to our client. So our client service is now the one that listens when there's a new person and then increments the counter on its own object. And that is where that logic needs to live. It shouldn't live anywhere else. And then at the same time, we have our common service that also listens to this person created event. And now it has the user's name, it has the client name, the client ID, the client email. It has everything that it needs. So it will then just go ahead and send the email. And like 3 and 4, 5, 6, and 7 happens in parallel because they're both listening to these events and they can happen independently of each other. So if our common service is down, then the client service can still increment its field. Or if the client service is down, then the common service can still send the email. So this asynchronous communication made our service much more reliable than it was before. If we just compare to this, we once again see that this call here to create a person would have waited a very long time for all of these steps to be completed. And if there was a problem at any one of these at any point in time, then that call would have failed. But we no longer have that problem. So what changed? I'm just borrowing 2 principles from Solid, and that is single responsibility and open and closed. Yes, so like I mentioned, that person service, it is only concerned about its own functionality. It only needs to store a person and do basic like CRUD operations, and it doesn't need to know about anything else. It will emit events to the bus, and then if it needs to do something, it can listen to those events. And that's what open and close means. Just it's very extendable, not like it was before, where you need to know, for example, where to get the data for a end destination. And then base consistency, which just stands for basic availability. So we mentioned that even if one of those client common services goes down, then the other ones can still operate. And that word was event carried state transfer. There's quite a few different words in the event storming and service-oriented architecture like fields, and that's actually one that I learned recently or like last year, and it really is great to decouple your services. But we're also introducing something called soft state, where now we're storing some of the client data on our other services, like that common service. And eventual consistency is also like tightly coupled with that, where it takes some time for that client data to propagate all the way to our common service. And I'm also going out on the streets. If you've heard of the CAP theorem before, it stands for consistency, availability, and partition tolerance. And if we look at our microservice, at what we did to decouple it, we basically favored availability and partition tolerance over consistency. And that's what most base systems will be. So this is just like a diagram of like where databases are on this model, which I thought looked very cool. And I just wanted to point out that we don't have consistency because it might take some time for that client data to propagate to the other services. But we have availability between our services, and we have partition tolerance where each service only stores its own data. And that's then about it. This is actually the picture that triggered the name change, where Twitter schooled me on the difference between a modular monolith and a distributed monolith. I'll maybe share it down there in the chat. But there's lots of other good points that you really have to consider before choosing microservices. And I guess the number one rule or like question you have to ask yourself is how many members and how many teams, because if you only have a single team and only a handful of members, I wouldn't even look at microservices. And then you can ask yourself all of these other questions, like have you done your research, and if you understand the challenges or not. And yes, then that's really it. I'm open for some Q&A. So these last few slides of that architecture diagram, that's actually from one of my blogs, and I have some code samples of that as well, of where the architecture was tightly coupled. And then part 2 is where all of that code all of that tightly coupled projects has a part 2, which where I swap out all of that for EventBridge, and then you can also deploy that and play around with it. It has some tests and things as well. So you can find me on Twitter and everywhere else, the blog, LinkedIn, and so forth. And yes, and I'm open for questions.
Rehan, is Derick here. Have you played with high volume events with EventBridge?
I can't really say that I have, but I do know the limits. So
Yeah,
in US
they have
East
some.
and EU West, you have to hit at least 10,000 per second, which if you do that for a minute, that's going to probably be like 700,000. But
Yeah, so it was quite awesome. We had a call with AWS and they can scale that thing quite a bit more, like 150,000. So that 10,000 is just to protect
Okay.
themselves. So
Well,
it's really great. So it's not a bad choice to use them. They can scale like crazy.
Actually very good to know. I didn't know that limit. I just knew that they can raise it.
No, they can. That's not a, yeah, I think it can go even more, and they're working on the product even. So maybe Andre can, if he's NDA isn't blocking him. But the thing is, that's really cool stuff they're doing, and it's a South African guy that's a product head for that in the US. Really awesome.
Okay.
So
I see one question from Tobias. How significant is the cost of communicating via EventBridge versus direct async HTTP calls? I don't think like the cost is really like your barrier there. It's mainly going to be about the systems involved. Can you afford that asynchronous communication between those two entities? If you can, then use EventBridge, I guess, or use HTTP calls, because sometimes you can't break it down to be asynchronous like this. Sometimes you have to make an HTTP call, and then you just can't use EventBridge.
So when you write your lambdas, right? Sorry, who's next? Yeah.
Sorry, Rehan, it's Niku. Will you be, I guess for that, you'll be able to trace the requests or the different microservices they're using something like X-ray, right? Because I saw you had a trace ID in the one payload. So that's what that's about, right? Something like that.
Yes. So X-ray actually doesn't track your services all that well. Like third parties services like Lamigo and Epsagon do a very good job, but otherwise you can just be creative about it, because you can actually, on different services, you can attach metadata like the SQS or the SNS, you can attach metadata, and then on the other side, if it's there, then you can, on that invocation, say that it came from there, and then you can connect all of your services using something like CloudWatch log insights, query over all of your Lambda functions and find all of the logs as that event went through all the way. But that's also a little bit tricky because you have to instrument basically all of the services. So what I did there is I just had that trace ID within the data payload. So all of my events within my AWS account always has like a control section where it's a trace ID, the version like for that specific event, and then the data part. And then that trace ID, if a different service sees that it's there, it will pick it up and then put it in its own logs so that we can connect all of the logs.
Rehan, when last did you use X-ray?
I'm not using it anymore. It just doesn't bring me all of that value in the beginning, or like every now and then maybe, but I'm not using it that much.
Yeah, we also saw it makes nice graphs and you can sort of see the connections between stuff, but then you forget about it. Maybe when stuff breaks, you might look at it, but I don't think it can get you enough info.
Yeah, so I'm using something called Rehan now at the moment, where it just logs basically when there's an error, it just logs the error and then the stack trace, but it's in a very nice and friendly like interface for you and your team, because then you can assign that ticket to somebody, or you can say that no, silence this like reoccurring event, and it's not too expensive. It's cheaper than the other ones that I've looked at and used. But like
Thank
it was
you.
more to medium projects.
Ray gun, like bzz,
Yeah, it's called
ray gun.
Rehan. Yeah.
Okay, cool. Cool.
Yeah. Any more questions? Sure, there has to be. Well,
I still have, sorry, I still have question for Derick before he left. So
Yeah.
it was more to do with the setup that you have, because you mentioned that you get like millions of requests that come through from EventBridge. So
Yes.
since your IDP is external, do you have like a direct connection between your AWS account and your on-prem IDP, or like a VPN link between the two that can sort of handle that traffic that has to go back and forth between AWS and your on-prem setup?
Yeah, we're lucky to have direct connect, so that helps us.
Okay.
Yes,
Okay.
no, without that, it would be way more painful and not feasible, actually.
Okay, all right, now cool. Right.
Yeah, and yeah, I think, yeah, it's awesome stuff, the AWS, the Lambdas and so on. It's really nice, and yeah, it is a learning curve, I must say. Event-based programming, or yeah, I'm trying to read books and understand it better, because it's totally different than what we were used to doing. And Rehan, I think you touched on a few things there. Sometimes you need to store duplicate data to actually be able to decouple the things. Otherwise, it doesn't make sense to really use them. So yeah, it's a new paradigm, and it's not as easy. So I hope it came through that just 3 requirements were a massive system. Well, in the old days, a massive system. In AWS, not so much, but still, it's many blocks to actually just do a few things.
Yeah. So if everybody just wants to fill in that survey, if you want to, we'll do a lucky draw in a few minutes, and then you can stand a chance to win one of 225 AWS dollar credits. But while you do that, I want to ask my question to Derick, or actually just a suggestion of something that I've done in the past, is where I've added the KMS encryption key on my Lambda function environment variable, and then gave that Lambda function the like permission to use that key. And then I actually stored my keys in something like a Redis or a DynamoDB, and then I would look it up and then just decrypt the key and then use it. Have you looked or considered something like that when you did that proposal?
No, because normally security will be on your case, so they sort of don't like that. So I would have liked to do it, but no, it's harder to sometimes deal with security and do it the longer way, unfortunately. But we also thought of doing it like that, but then decided not to. I think your solution might be better in the long run, but yeah, if you want to be agile, sometimes you need to do some of the things a bit different in a bigger place that's more governed with security. But yeah, the Redis thing, we actually wanted to use DynamoDB with DAX to do that. So
yeah, very nice.
Yeah, so almost, but not totally. Where did you put the survey, right, Rehan?
I'm trying to find the chat again.
Oh, there, entry for, I don't, oh, there, Bitly, that one.
There it was. No, it's not.
Let's see. I still need some vouchers to pay off my debt in my personal account to AWS. Andre, you need to help us out, man.
I don't know if I can help, because I also want some of that for my URL side project.
Okay. I'm gonna go ahead and then take those names. Do we have any more questions? Andre, you want to say something?
No, nothing on my end. Is that the link for the survey?
Yeah.
The bit.ly.
Okay.
Are you using your warp, your shortener, or is that the bit.ly stuff?
No, not using that anymore. It's still active, it's still there, and that's our project of mine. But no, that's on the side for now. It can stay there. I'm focused on other stuff. It's a very nice experience. Thank you.
Rehan, if we've got some time, have you looked at something like Kafka or Nats, one of those streaming platforms to use as the event bus in your microservices architecture?
I haven't actually. I've mainly played with SQS, and then EventBridge, SNS, Kinesis, and then also Redis streams and queues, like quite a few years back. But since then, I've been using mainly AWS services and finding ways around some of these limitations and using it. So I don't know, maybe somebody else has some experience with that. I know like RabbitMQ is also a very popular one. Why do you ask, Cole?
It's some interesting things you can do when you've got, like, I've built like, it was during a hackathon, we wanted to see if you can do it, and we used Nats as our messaging bus. I mean, it has, when you use Jetstream on it, which is like the streaming part of it, it's got persistence, so you don't lose events. So if a service goes down for whatever reason, one of your microservices, it keeps track of where it is or where it was lost, and it will then you'll be able to kind of replay everything you've lost and catch up.
What is Nats?
So that, like, just bare bones Nats, you can probably compare it with something like RabbitMQ. They've got it used to be called Nats streaming, but it's now called Jetstream. And Jetstream is like it's not Kafka. It's not as advanced as Kafka, but it gives you a lot of the functionality that you would get out of Kafka, and it's like a full streaming platform. You've got stream processors and all those cool things.
Okay, is
very,
it
very
Nats.io? Is it this?
That's the one. That's the one.
Okay.
You read up a bit on the founding team. You can see they've done some interesting things in their, like, event processing.
Yeah, Tinder,
like
many
world.
events.
All those swipes.
That's
So yeah, interesting. Now I was just wondering, like, Rehan, with the microservices stuff, if you've fiddled with other messaging buses.
Anything else? Anyone? If not, then we're going to do the lucky draw. I think you can still see my screen. So this is everybody that's filled in the survey, and we're going to click spin.
So just something, you must stop on Cherian's name, because then you can do the next talk. That's what you didn't say, right? With the credits come a talk. Oh,
Derick, you can't say that about me.
Okay, Tobias, what's your topic going to be? Before I hand out the credits? No, we're just joking. Okay, I'll send you these credits via email, and then we're going to choose another name. 2 of them.
Yeah. See, so we're actually buying people, Rehan, to give talks. Oh, Paul, you're going to talk again.
Nice, Paul.
Yay, Nats.
How I spent my $25.
I actually think, like, we must have an event, like if we have another hackathon or something, of who can spend their $25 within AWS the most efficiently, or who can build the coolest thing. And I think that can be a challenge. Like, what can you build with $25? Like, how will you spend that? Build something cool.
You could also put a spin on it and say, who can spend the $25 the fastest?
No, but there's so many ways.
Yeah,
Just
that's a
spin up
good
an
idea.
EKS cluster.
Yes.
Okay,
Yeah,
then,
according to
I decided to
Derick-
do three.
according
So,
from what from Derick
you're
earlier,
winning as well.
and create a bunch of users and make them log in or something.
Yes, exactly. Cognito. Yeah.
Yeah, well, that's it. I'll send Tobias, Dirk, and then Paul. I'll send you your vouchers. And thanks everybody for coming. And yeah,
Thank
well,
you.
that's it.
Yeah, thanks,
Awesome.
We'll
guys.
see you
Thanks,
at the
guys.
next one.
Thanks.
There will be one more in November, and in December we're taking a break because it's like reInvent, and I'm just like totally tired from all of those announcements and what's going on. Even though I'm not going, I wish I was, but just like keeping track, like on a social level, is already something, a full-time job.
Yeah,
Isn't
we
it because you're married?
No, it's still recently the same day, like day-to-day activities. I can't say like nothing changed.
Rehan, we should definitely do one maybe then in January, like about all the reInvent stuff, because I know that it's
Yes, there's
difficult to
usually
keep up
like
with all those announcements.
It's usually like
Ask-
reInvent recap now.
Cool.
Ask Kobus again. I mean, he needs to do it for his job, so he can just come and give the reInvent stuff.
Yeah.
I actually forgot to give a shout out to our sponsors, Swipe IX, where I'm currently working at, and also Digitata, where Niku is working at. Thank you for sponsoring at the meetup a little bit.
Cool, man.
And yeah.
Yeah, thanks, Niku.
No problem.
That's it.
Co-
Thank you,
con-
guys.
Okay,
Have
everyone,
a good evening.
enjoy the rest of your night. Eh?
Cool. Thanks.
Thank you,
for
everyone.
coming.
Bye,
Thank you, bye.
guys. Thanks,
Thanks, guys.
Derek. Thanks, Rehan.
Bye.
Bye.
Bye-bye.